Good morning, all my Math 150 students. How's everybody doing today? I want to get you guys set up for the next section. We're going to be looking at several short videos today on section 2.4, which is properties of parabolas. We're going to start off by looking at the following equation that we talked about earlier. We've got the standard equation of the parabola that y equals ax squared plus bx plus c. And our goal today is to try to find the vertex of this parabola. And the vertex, if you don't remember, is either that highest point if your parabola opens downward or the lowest point if your parabola opens upward. There were a couple of ways to find it. We're going to talk about two today. One way to find this is to convert this into a different form. If we are able to convert this into the form y equals a times x minus h quantity squared plus k, if we're successful in doing that, we can actually read the vertex right from it. The vertex is going to come from these two values, hk. So anytime we can get it into this form, which we might call vertex form, the parabola, the vertex will be the values of h comma k, and that will tell us the most important point on that problem. Now, you may recognize from yesterday that we have a factored equation here, a factored expression that turns into a perfect square. So the way that we are going to do this is we're going to make use of the complete square method. So just like yesterday, we're going to have to start and find that mystery number so we can turn this into a perfect square. So let's take a look at an example so you can see this in action. Right here, I'm asking you to graph a quadratic function. The directions are really just to find the vertex. We're not going to go all the way to the final graph, but we want to find the vertex. So we want to get a perfect square out of this. So in order to do that, we're going to make use of the complete the square method we talked about yesterday. So let's go see what we can do with that. So just like yesterday, we're going to take those first two terms and we're going to do the pushover. We're going to move that 10 out of the way because that 10 is not the right value to get us a square. So we're going to come back and we're going to figure out what that value should be. We're going to add it here. But to keep the balance, whatever goes in that first blank has to go in that second blank so we don't change the value of the equation. So remember from yesterday, the way we find that mystery number is we use the formula negative b over 2a, negative b over 2 quantity squared. Okay, negative b over 2 quantity squared. So in this case, that's going to be negative 4 over 2 quantity squared. When we find that value, we're going to get 2 squared, and that's going to equal 4. So the value that we need to help us complete the square is positive 4. We put in that spot. But to keep the balance, we need to put a negative 4 there. It's imperative that we don't change the value of the equation. So now, continuing with this, we're going to get that y is equal to x squared minus 4x plus 4, and we're going to group that together. And now these two leftover pieces are going to become plus 6. And we're just going to kind of leave that on the outside because that's not part of our perfect square. From here, we are going to factor this to x minus 2 quantity squared, and then we're going to leave that 6 on the outside. So if you remember from before, the form we're looking at is to get this into a times x minus h quantity squared plus k. We have got a match now. We know our h value is 2 and that our k value is 6. So the vertex of this parabola is located at the point 2 comma 6. And that's the answer we're looking for. Now, one of the really common mistakes in this problem is looking at the h value. And the reason I say that is because people see this as a negative 2, and they assume that the vertex value has an x value of negative 2 for that reason. Keep in mind that the formula has a negative built into it, so that's already accounted for. So the bottom line is when you're trying to find the x value, if you look at this location with the sign included, it will always be the opposite sign of what you're seeing. So the x value here, we're looking at the equation, we literally see negative 2. That means our vertex will have a value of positive 2. Now on the outside, we've got a plus k. So that means whatever this is, it will look exactly like it in our point. So we see a positive 6, our vertex will have a positive 6. So it's a direct match. So it kind of looks like you're switching the sign on the x and you're keeping the sign on the y. And it's because of the formula, it says minus h and a positive k. So that's one way of finding the vertex of a parabola. Now there is a second way you can find the vertex of a parabola. That second way you're going to find the vertex of a parabola is to make use of another formula. So let's start with f of x equals our x squared. And I'm going to use the same equation here. It's going to be x squared minus 4x plus 10, x squared minus 4x plus 10. And let's say that you don't want to go through the trouble of completing the square. There is a built-in formula for degree twos that can help you to find the vertex. So any problem that has a equation, y equals ax squared plus bx plus c, we can use the formula x equals negative b over 2a, and that will give us the x value of the vertex. Now, the benefit of this is that we don't have to complete the square. We can get it directly from the equation. The downside is we don't know what y is yet. Okay, we're still not going to be able to figure out what y is, but we'll show you how to handle that in just a moment. So coming over here, we're going to use this formula, and we're literally just going to use negative b over 2a. So our b value is negative 4. Our a value is going to be 10. And what we're going to end up with is that our I'm sorry, our a value is not 10. Our a value is 1. My mistake, a value is 1. And then what we're going to end up with is positive 4 over 2, which gives us that x value of 2. So the x value of our vertex is 2. So if we're trying to come up with our vertex, we now know we have a 2 in that location. We're still looking for the y value. This is where the beauty of functions come in. We were given a function, and functions want inputs so they can get outputs. Our question is, what's the y value when x is 2? In other words, what's the output of our function when x is 2? So we go to that function, and we get ready to plug in by using our somethings. So we're going to get something squared minus 4 times something plus 10. We're plugging in our 2, and now we're going to compute this. And we're going to get 4 minus 8 plus 10. If we do 4 minus 8 plus 10, that ends up giving us 4 minus a is negative 4 plus 10 is 6. So now we know the y value at 2. In other words, f of 2 is 6. And that's going to be our vertex. So we are going to get the exact same value for the vertex that we got before. So it doesn't really matter which form you use. Both are acceptable to find the vertex. In the complete the square method, you get the x value and the y value directly from the equation. In the shortcut method, you don't get the y value. You use x equals negative b over 2a. But then when you get the x value, you plug it back into the function, and that gives you the y value. Finding the vertex of a parabola is going to be one of the main skills we need from this section. I hope that makes a lot of sense to you guys. I'm going to come back pretty soon with a couple more videos to wrap up section 2.4.